Today we're going to talk about least common multiple and greatest common factor. The first thing we have to do when we talk about least common multiple and talk about greatest common factor is talk about divisibility. A number that is divided by a smaller number without a remainder is divisible by that smaller number. So, for instance, if we have the number 24, 24 divided by 6 is equal to 4. So 24 is divisible by 6. 24 is also divisible by 4 because if we can get no remainder when we divide by 6, we'll also get no remainder when we divide by 4. But for right now, 24 is divisible by 6. 24 divided by 5 equals 4 with a remainder of 4. So 24 is not divisible by 5 because there is a remainder when we divide. 24 is divisible by 6 because there's no remainder. There are divisibility rules, divisibility algorithms that let us know what numbers are divisible by other numbers. So a number is divisible by 2 if it's an even number. So even numbers are all numbers that end in 0, 2, 4, 6, or 8. Any number that ends in one of those numbers is even and therefore is divisible by 2. A number is divisible by 3 if you add the digits of the number and the sum of the digits is divisible by 3. Then the original number is divisible by 3. So, for instance, 1, 2, 3, 3. 1,233. If we add those digits, we get 1 plus 2 plus 3 plus 3. So 1 plus 2 is 3, plus 3 is 6, plus 3 more is 9. 9 is divisible by 3, so 1,233 is divisible by 3. If we have a number, say 1, 2, 3, 4, and add those digits, that would be equal to 10. 10 is not divisible by 3, so this one is not divisible by 3. Let's keep the one that is divisible by 3 up there, and we'll erase our other example though. A number is divisible by 5 if the number ends in a 5 or a 0. A number is divisible by 6 if the number is divisible by both 2 and 3. So that means that you do the divisibility rule for 3 and it's an even number. There is a rule for 7, but it's really convoluted, so you don't have to worry about the divisibility by 7. A number is divisible by 9 if we add up the digits and the sum of the digits is divisible by 9. The original number is divisible by 9. So 1,233, we added up the digits and that's equal to 9. So 9 is divisible by 3. So 1,233 is also divisible by 9. And last, a number is divisible by 10 if it ends in a 0. So let's see what we can do with all these divisibility rules. So here we have some numbers: 112,260, 258, 143, 855, 624, and 110. And we want to find out if these numbers are divisible by these numbers. So let's start out with 2's. Are these numbers even or odd? 112,260 is even because it ends in a 0, so it's divisible by 2. 258 is even because it ends in an 8, so it's divisible by 2. 143 is odd. 855 is odd. Those two are not divisible by 2. 624 is divisible by 2, and 110 is divisible by 2. Let's skip 3 for a second, because 3 and 9 we're going to do the same thing for, and then to figure out our divisibility. So let's do the other ones because these are the ones we can just look at. 5, we're looking for divisibility for 5, so it needs to end in a 5 or a 0. 112,260 ends in a 0, so that's divisible by 5. 258 is not a 5 or a 0. 143 is not a 5 or a 0. 855 is a 5, ends in a 5. 624 is not a 5 or a 0. 110 does end in a 0, so that one's divisible by 5. Let's check our divisibility for 10. The only two numbers that end in 0 are 112,260 and 110. Those two are divisible by 10. For 3, 6, and 9, we have to determine the sum of the digits first. So the sum of the digits of 112,260 is 1 plus 1 is 2, plus 2 more is 4, plus 2 more is 6, plus 6 is 12. So the sum of those digits is 12. The sum of the digits for 258 is 2 plus 5 plus 8, so that's 15. The sum of the digits for 143 is 1 plus 4 plus 3, so that's 8. The sum of the digits for 855 is 18. The sum of the digits for 624 is 12, and the sum of the digits for 110 is 2. Now we have to determine which of these numbers is divisible by 3. 12 is divisible by 3, so that means 112,260 is divisible by 3. 15 is divisible by 3, so 258 is divisible by 3. 8 is not divisible by 3, so 143 is not divisible by 3. 18 is divisible by 3, so 855 is divisible by 3. We already said that 12 was divisible by 3, and 2 is not divisible by 3. So let's look at these numbers again and determine which ones are divisible by 9. 12 is not divisible by 9, so 112,260 is not divisible by 9. 15 is not divisible by 9. 8 is not divisible by 9. 18 is divisible by 9, so 855 is divisible by 9. 12 and 2 are not divisible by 9. So now the last column we have to fill out is the ones that are divisible by 6. Our rule for 6 was that it was divisible by both 2 and 3. So the ones that have check marks in 2 and 3 are divisible by 6. So 112,260 has a check mark in 2 and 3. It's even and it's divisible by 3, so it's divisible by 6. 258 is divisible by 2 and 3, so it's also divisible by 6. 143 is not divisible by any of the numbers we have figured out so far, so That's okay. 855 is only divisible by 5, or by 3. It's not divisible by 2, so it's not divisible by 6. 624 is divisible by 2 and 3, so it is divisible by 6. And 110 is not divisible by 3, so it's not divisible by 6. Why do we want to know about divisibility? Divisibility helps us when we start trying to figure out common factors, when we start trying to figure out prime factorization, and when we start figuring out how to simplify fractions. That's why divisibility is so important, and understanding these rules is so important. That way you don't have to divide really big numbers a lot of times to figure out what the divisibility is. For instance, for the 112,260, that's a large number, and to have to figure out all these divisibility properties, the only thing we had to do was, the only operations we had to do was add up the digits to equal 12. Then we knew which numbers, 2, 3, 5, 6, 9, and 10, it was divisible by. So if we want, now if you want to do the division, you can, but you don't have to. A factor is a number that is multiplied to another number to produce a given number. So let's deal with some little smaller numbers at this point so we can talk a little bit more about them. That's one of the things a lot of mathematicians do, is make things smaller and then see how it relates to bigger things. So if I can work with small numbers, I know that it's going to work the same way with bigger numbers. We just have to understand what's going on with the smaller numbers, and then that makes it easier for us to work with the bigger numbers. So a factor is a number that is multiplied to another number and produces a given number. It sounds like a lot of words, but we'll look at the number 30. The factors of 30. Are what multiplies to 30? So 2 and 15. 2 times 15 is 30. 3 times 10 is 30. 5 times 6 is 30. So the factors of 30 are 2, 3, 5, 6, 10, and 15. Prime factorization are all the prime numbers that multiply together to produce a given number. This is what we're really going to worry about the most, is prime factorization, because it makes finding least common multiples and greatest common factors much easier. The small prime numbers, the prime numbers less than 20, are 2, which is the only even prime number, 3, 5, 7, 11, 13, 17, and 19. Those are our prime numbers less than 20. So let's find the prime factorization of these numbers. 4 is 2 times 2. So 2 times 2 is 4, and 2 and 2 are both prime numbers. So the prime factorization for 4 is 2 times 2, or you can also write it as 2 squared. The prime factorization for 10 is 2 times 5. 2 and 5 are both prime numbers, so the prime factorization for 10 is 2 and 5. 48 and 56, these are a little bit larger numbers, so let's talk about how to find the prime factorization. You can find the prime factorization by knowing two numbers that multiply to 48 and going from there until you get all prime numbers. So we know that 24 is 2 times, or 48 is 2 times 24. 24 is 2 times 12. 12 is 2 times 6, and 6 is 2 times 3. So our prime factorization for 48 is 2 times 2 times 2 times 2 times 3, or 2 to the 4th times 3. If you don't know that, one of the reasons we did the divisibility is because then you can just use your divisibility rules and say this is even and divide by 2. This is even and divide by 2. This is even and divide by 2 again. Or if you know that 48, for instance, is 3 times 16, you could do it that way. And then we know that 16 is 4 times 4, which is, and 4 is 2 times 2, and then we have another 4, which is 2 times 2. Our bottom row here, and this 3, those are all our terminating parts of the tree, is 2 times 2 times 2 times 2 times 3, so 2 to the 4th times 3. So it doesn't really matter how you start, it's just that when you're finally done, your terminating parts of all of this tree are all prime numbers. So 56 is 7 times 8, and 8 is 2 times 4, which is 2 times 2. 56 is then 2 times 2 times 2 times 7, which is 2 to the 3rd times 7. You can write it either way. Least common multiple is the smallest number that is a multiple of 2 or more numbers. So, for instance, we have, let's say, 5. Our multiples of 5 are 5, 10, 15, 20, 25, 30, 35, 40. Do you see where the divisibility rule came in for having 5s or 0s at the end? So those are the multiples of 5. Multiples are bigger. Multiples make things, remember multiplying made things bigger, so multiples are bigger. Let's do the multiples of 6. The multiples of 6 are 6, 12, 18, 24, 30, 36, 42, and you can keep going. Both of these keep going forever. The least common multiples, so the smallest number that is a multiple of 2 or more numbers. So the smallest common multiple of these, the first number that's in the same that's in these lists is 30. So the least common multiple, the LCM of 5 and 6 is 30. And this is one way to find least common multiples. Unfortunately, if this number gets large, or both of these numbers get large, this is going to be a very challenging way to do it. And I also want you to remember, as we're working further down in this section, 5x, x can be any number. Any number times 5 is a multiple of 5. So 5x is a multiple of 5. So that's one of the things we kind of got to keep in mind also. But we'll show you that in a few minutes. So let's find the least common multiple of 4 and 10. So what you could do is start listing multiples of 4, 4, 8, 12, 16, and 20. And say, oh yes, I think that's right, because 10, 20. So 20 is a multiple of 4, and it's also a multiple of 10. So the least common multiple of 4 and 20 and 10 is 20. The problem is now if we want to find the least common multiple of 48 and 56, these are large numbers. So instead of doing it this way, there's another way to do it. 4, we found the prime factorization for 4. 4 was 2 squared, or 2 times 2. And 10 was 2 times 5. So when we find the least common multiple, we want all factors, all prime factors of both numbers. But you don't need overlaps. For instance, here, there's one, oops, that covered it up. I didn't want it to cover it up. There's 1, 2, I'll rewrite that 2 in blue in just a second. There's 1, 2 in each of the factors. There's a 2 and there's a 2 here. We only have to write that once. So we have the 2 that's from the yellow. We'll underline that in yellow. Oops. And then we also have this 2. And we also have this 5. So if we look at 4, 4 is 2 times 2. Here we have 2 times 2 in here. Now 5 is 2 times 5. We also have written 2 and 5. So all of these numbers are taken care of in this number here. So the least common multiple is 2 times 2 times 5, which is 20. And 10. Why do I keep saying it's a different number other than 10? So the least common multiple of 4 and 10 is 20. Let's look at this again. We'll erase all this and start over. Let's look at this with 48 and 56. So for 48, we said that was 2 times 2 times 2 times 2 times 3. 2 to the 4th times 3. And 56 was 2 times 2 times 2 times 7. 2 to the 3rd times 7. When we look, we have 3 2's over here and 3 2's over here. And then left over, for 48 we have a 2 times 3, and for 56 we have a leftover 7. So our least common multiple is going to be 2 times 2 times 2, from where our yellow was, and then we have 2 times 3 for the orange part, and we have the 7 as our final. Now if we multiply that all out, we get 2 times 2 times 2 times 2 times 3 times 7. That didn't work out right. That is 336. Sorry, my fingers weren't working quite right. If we had to write out 48 plus 48 plus 48 until we got to 336, and then 56 plus 56 plus 56 until we got to 336, that would be a long time. But this way, we're able to figure out the least common multiple and the greatest common factor in a couple minutes by just listing out the prime factoring and see what we need. So let's add some variables in there and see if we can extrapolate. So the first thing you do when you have variables and numbers is look at our numbers. So we knew that the least common multiple of 4 and 10 is 20. So now we want to find the least common multiple of 4x squared y cubed and 10x to the fourth y. Now we want to look at, so we found the least common multiple of 4 and 10 was 20. Now we want the least common multiple of x squared and x to the fourth. X squared is x times x. X to the fourth is x times x times x times x. So just like we did with the 2 to the, this one was 2 squared and this was 2, and we kept both 2's in there, the same thing happens here. So the least common multiple of x to the x squared and x to the fourth is x to the fourth. Because think x squared times x is x to the fourth. That's x to the fourth is a multiple of x squared. The same thing with y cubed and y. The least common multiple is y cubed. So if we're looking at 4x squared y cubed and 10x to the fourth y, our least common multiple is 20 x to the fourth y cubed. We have 48 a, b, c, d, and 56 a squared c to the fifth. So we want to find our least common multiple. Remember, 48 was 2 to the fourth times 3. We have a, b, c, d. 56 was 2 to the third times 7, and then we have a squared c to the fifth. Looking at it over here, when we had the same base, we took the larger of the two exponents. So when we have the same base, we're going to take the larger of the two exponents. You can do that same thing with our numbers as well as our variables. So we have 2 to the fourth and 2 cubed. The larger of the two exponents is 2 to the fourth. And that makes sense because 2 cubed times 2 is 2 to the fourth. That's a multiple. 2 to the fourth, 3 is, there's no 3 over here, but we still need it, just like we needed the 5 from over here. So we need the 3, and we need the 7. And now we're looking at a and a squared. The larger of the two exponents is a squared. B, and there's no b, so we just need the b. C and c to the fifth. We need the larger of the two exponents, so c to the fifth. And d, there's no d in this one, but we do need to keep it, so it's d. And we figured out that this was 336. 2 to the fourth times 3 times 7 is 336. A squared, b, c to the fifth, and d. You could also leave it like this and not do the multiplication yet in your calculator. You could just leave it like that if you wanted. Greatest common factor is the largest factor or number that divides two or more numbers. So for instance, if we have 30 and 24, both of these numbers are divisible by 2 because they're 2 times 15, or 2 times 24, 3 times 10, 3 times 8, or 5 times 6, and 6 times 4. So these numbers, they're both divisible by 2. They're both divisible by 3. And they're both divisible by 6. 6 is the largest of the two numbers. The largest factor of the two numbers that's divisible by each number. So let's find the greatest common factor. Again, we can find the prime factorization for all of these, and it's a little bit easier to find than the greatest common factors. So the prime factorization for 4 was 2 times 2. The prime factorization for 10 was 2 times 10. Both of these two numbers have a 2 in it, and that's the only thing they have common. So the greatest common factor of 4 and 10 is 2. The greatest common factor of 48, remember 48 was 2 times 2 times 2 times 2. There were 4 2's and a 3. And 56 was 2 times 2 times 2 times 7. Both of these numbers have 3 2's in it. So that's the only thing common in these two. So the greatest common factor of 48 and 56 is 2 times 2 times 2, which is 8. I want to point out, remember 48 was 2 to the 4th times 3, and 56 was 2 to the 3rd times 3. Notice it's the same base, they both have a 2, and for greatest common factor, we're going to do the opposite of least common multiple. We're only going to take the smallest exponent, and the factor has to be in both numbers. So least common multiple, we took the largest exponent in all the factors. Greatest common factor, we take the smallest exponent in only the common factors. For those of you that know about intersections and unions, greatest common factor is an intersection, least common multiple is a union. Let's look at these. Let's write out all our prime factorization and go from there. So 4 was 2 squared, and then we have x squared and y cubed, and 10 was 2x to the 2 times 5. Two times 5, x to the 4th times y. So we want everything that's in both of them. Let's look at our bases first. There's a 2 in both, and there's an x in both, and there's a y in both. There's no 5 in this one, so 5 is not going to be in our greatest common factor. Now we're going to take the smallest exponents on each of these factors. The exponent on the first 2 is 2, and the exponent on this 2 is 1, so our smallest exponent is 1. The exponent on the x squared is 2, and the x to the 4th is 4. The smallest exponent is 2. And then the exponent on the y cubed is 3 and the y is 1. So here's our greatest common factor. Our greatest common factor of 4x squared y cubed and 10x to the fourth y is 2x squared y. Let's look at 48a, b, c, d and 56a squared c to the fifth. So our prime factorization was 2 to the fourth times 3 for 48, and we have a, b, c, d. And our prime factorization for 56 was 2 to the third a squared c to the fifth. We want the common factors, so they both have a 2, and the smallest exponent would be 2 cubed. There's no 3 in both of them. Oops, I forgot the 7 in the 56, probably because I was thinking we didn't need it anyway. There's no 3 or 7 in the opposite ones. There is an a in both of them, and the smallest exponent is a to the first. There's no b in the 56a squared c to the fifth, so we can't include b. There is a c in both of them, and the smallest exponent is 1, and there's no d. So our greatest common factor for 48 a, b, c, d and 56 a squared c to the fifth is 2 cubed ac, or 8 ac. So let's look at all of these. There's a couple different possibilities. So the least common multiple of 4x squared y cubed and 8x cubed y to the seventh. The multiple one is going to be the larger. Great, the factors are smaller. So the least common multiple of 4 and 8 is 8. 8 is a multiple of 4. And then the larger of the exponents, x to the fourth and x cubed. We have x to the fourth, y to the third, and y to the seventh. We have y to the seventh. Greatest common factor, we need to go smaller. So the greatest common factor of 4 and 8 is 4, because 2 times 4 is 8. And then we need the smaller of the exponents, so x cubed and y cubed. 15 is 3 times 5. 20 is 2 times 2 times 5. So our least common multiple for 15 and 20 is going to be all of the factors times. So it's 2 times 2 times 3 times 5, which is 60. The greatest common factor is the only factor that's common in both of them, so the 5 is the only thing that's common in both. X plus 1 and x plus 4. X plus 1 is one number, and x plus 4 is another number. So while you're getting used to it, you could put a number in there just to think about what you're doing. So if we put 1 in for x, we would have the number 2. If we put 1 in for x here, we would have the number 5. If we want the least common multiple, we would have to multiply 2 times 5. So if we have x plus 1 and x plus 4, we have to multiply x plus 1 times x plus 4. The greatest common factor of 2 and 5, there is no number that multiplies to 2 and 5 other than 1. So the greatest common factor of x plus 1 and x plus 4 is 1. Again, what's in parentheses is one number. What's in parentheses is one number. So the least common multiple of 5x minus 4 times x plus 1 and x minus 4 times 5x minus 4, we're going to multiply all the factors together, just like we did here. We did 2 times 2 times 5 and 3 times 5, the least common multiple was 2 times 2 times 3 times 5. Notice we only wrote that 5 once because it was in both. Even though it was in both, we only wrote it once because it covered both. So the least common multiple covered 2 times 2 times 5, and then separately covers 3 times 5. So our factors for this are 5 minus 4 and x plus 1. Our factors for this one are x minus 4 and 5x minus 4. This is actually a prime factorization. It's just not one you're used to seeing because it doesn't have actual numbers in it. So we're going to write out all our factors. So our factors are 5x minus 4, x plus 1, and x minus 4. You don't have to write this 5x minus 4 twice because it's already in here. If you look, we have 5x minus 4 times x plus 1. That's our first number. And then look again at our second number and make sure all those factors are in. 5x minus 4 is here and x minus 4 is here. The greatest common factor of 5x minus 4, x plus 1, and x minus 4, 5x minus 4 is 5x minus 4. That's one of the two factors in both of these, and it's common. The least common multiple of 7 and 13, again, 7 and 13 are both prime numbers, so there is no common factors with it, or there couldn't be. So we can actually just multiply, because this is 7 times 1 and this is 13 times 1. So to find the least common multiple, we would multiply them together and get 7 times 13, which is 91. And the greatest common factor, if this is 1 times 7 and this is 1 times 13, the greatest common factor is 1. Least common multiple of 6x squared, 4x, and 18. So 6x squared is 2 times 3 times x squared. 4x is 2 squared times x. And 18 is 2 times 9, which would be 2 times 3 squared. If you have to, you can do a factor tree to find that one out. The least common multiple is all of our factors and the largest exponent. So all of them have a 2, and the largest exponent on the 2 is squared. We need a 3, and the largest exponent on the 3 is squared. And we have an x, and the largest exponent on the x is squared. So this is 2 squared times 3 squared times x squared. 2 squared is 4, 3 squared is 9, so 2 squared times 3 squared is 36 x squared. The greatest common factor of these three, only the numbers that are common, only the factors that are common, and the smallest exponent. So all three of these expressions have a 2, and all three of these expressions have an x. The smallest exponent on the 2 is 1, and the smallest exponent on the x is 1. So our greatest common factor is 2x. Our least common multiple, we want the variable with the highest exponent, so it's x squared, and the greatest common factor is x. So just as a little recap, least common multiple is all factors and the largest exponents. Greatest common factor is the common factors and the smallest exponents. One of the reasons we want to find the greatest common factor is to factor out the greatest common factor. So when we're factoring out the greatest common factor, we're multiplying two things together so that they multiply. When we're done, if we remultiplied, we would multiply them and get this back. So the first thing you want to look at is the greatest common factor of 4 and 14. To factor out the greatest common factor of 4W and 14. The greatest common factor is just 2. 4 is 2 times 2. 14 is 2 times 7. So the greatest common factor of 4W and 14 is 2. So if we factor out a greatest common factor, we have 2. And then you think, what do I need to multiply 2 by to get 4W? I need to multiply 2 by 2W to get 4W. And then I need to multiply 2 by 7 to get 14. So to factor out the greatest common factor of 4W minus 14, we have 2 and then parentheses 2W minus 7 and end our parentheses. And then to check our answer, we can remultiply. 2 times 2W is 4W, 2 times minus 7 is minus 14. Let's factor out the greatest common factor of x squared and x. We've looked at our previous slide, and the greatest common factor of x squared and x was x. So we're going to factor out an x, and then use our parentheses. What do we need to multiply x by to get x squared? We need x. What do we need to multiply x by to get x? We need to add a 1. So then when we remultiply to check our answer, x times x is x squared, x times 1 is x. Many of my students make the mistake, I'll put it in red so that we know that it's a mistake, and when we factor this, we get x times x. This would just be x squared. There's no plus x on there. So it's not, this is not the factorization for this one. So make sure to always check your answers, especially with factoring, because it's one of the really easy things to check answers with, and it's also one of the things then that you know you're doing it right. Change our color back to blue. Now, if we have a minus sign on our leading coefficient, the coefficient with the highest degree term, we want to factor out our minus sign also. So here we have minus 6x squared plus 4x minus 18. All three of these have a 2. The greatest common factor of all three of these is 2. Remember, we had, ooh, I made a mistake on that one. Let's erase that so we do it correctly. There's no x in the 18, so there's no, there was no, I had 2x here, not 2. There's no x in the 18, so that's not part of the factors. So make sure you get that changed if you wrote down what I wrote down. So our greatest common factor of 6x squared, 4x, and 18 was 2. So our greatest common factor to factor out of negative 6x squared plus 4x minus 18 is negative 2. We want to factor out that negative 2 because if we have to factor more, it's easier if you have the negative factored out. So then what do we need to multiply negative 2 by to get negative 6x squared? We need to multiply that by 3x squared. What do we need to multiply negative 2 by to get positive 4x? We need to multiply that by negative 2x. What do we need to multiply negative 2 by to get negative 18? We need to multiply that by plus 9. So then let's double check our answer. Negative 2 times 3x squared is minus 6x squared. Negative 2 times negative 2x is positive 4x. And negative 2 times positive 9 is minus 18. So that one's good. This last one, we have 3x times x minus 2 plus 4 times x minus 2. Our greatest common factor of these two is x minus 2. We also did this same process when we were adding and subtracting in sections 2.1 and 2.2. Any way you think about it, it's all working the same. So you can think about it as combining like terms, or you can think about it as factoring out the greatest common factor. But the greatest common factor is x minus 2, so we're going to factor that out. And just like we did here when we factored out our x minus 2, we then put parentheses, or here, or here. What do we need to multiply x minus 2 by to get 3x times x minus 2? We need to multiply by 3x. Plus, what do we need to multiply x minus 2 by to get 4 times x minus 2? We need 4. So that's how that works. Next, we're going to simplify rational expressions. Here are the steps for simplifying rational expressions. We want to factor the denominator if needed. Then we want to find the least common denominator. The reason we're factoring the least common denominator is because, or factoring the denominator is then finding the least common denominator is easier. Once we find the least common denominator, we want to multiply each term by what is missing in the least common denominator. Then we want to actually perform the multiplication. Combine like terms in the numerator. Simplify if possible. So, we're going to add and subtract our rational expressions from all of these. Our least common multiple, or our least common denominator for 15 and 20 was 60. If you look back on that chart that we found, most of these are on there. So our least common multiple for 15 and 20 is 60. So we need to multiply by what's missing. So 4 over 15, 15 times 4 is 60, so we need to multiply by 4 over 4. And then we're adding 7 over 20. 20 times 3 is 60, so we need to multiply by 3 over 3. So here we have 16 over 60 plus 21 over 60 is 37 over 60. So 4 over 15 plus 7 over 15 is 37 over 60. 15 and 21 is our denominators. So 21 is 3 times 7. 15 is 3 times 5. So our least common denominator is going to be 3 times 5 times 7, or 21 times 7 would be 105. So when we add and subtract our fractions, we want to do 5 over 21 times, we need that 5 in there, so 5 over 5 minus 7 over 15 times 7 over 7, that's equal to 25 over 105 minus 49 over 105. So that is negative 24 over 105. Let's check and see if these are divisible by 3. 24 is 2 plus 4 is 6. 6 is divisible by 3, so 24 is divisible by 3. 105 is 1 plus 5, which is 6, so that one's also divisible by 3. So let's divide numerator and denominator by 3. So we have negative 8 over 35. So that's our final answer. So 5 over 21 minus 7 over 21 is negative 8 over 35. One of the things, one of the reasons to use a least common denominator versus just multiplying by the first fraction by the second denominator and the second fraction by the first denominator is, number one, you're going to get much smaller numbers, and number two, even though we had to reduce this time, many times when you find the least common denominator, you don't have to reduce anything. Alright, I'm going to erase all this. If you need it, you can go back and pause. So then I have more room to do these. So this one looks very, very complicated, but remember our least common denominator that we found previously was 16 x to the 4th y to the 7th. So now we just need to multiply by what's missing. So we have 2x squared over 8x squared y. So we have 2x squared over 8x squared y, and we need to multiply to get 16x to the 4th y to the 7th. So we're going to multiply 8 times 2 to get 16, x squared by x squared to get x to the 4th, and y times y to the 6th is y to the 7th. Whatever we do in the denominator, we need to do in the numerator. So we're going to multiply by 2x squared y to the 6th minus, our first fraction is 5y cubed over 16x to the 4th y to the 7th, and we need to multiply by, that's already our denominator, so we don't need to multiply by anything. So let's multiply out the first numerator. We have 4, 2 times 2 is 4, x squared times x squared is x to the 4th y to the 6th minus 5y cubed over 16 x to the 4th y to the 7th. And you're done. This is reducible. We'll talk about more how to reduce it later, but the numerator we could actually factor out a y cubed because they both have y cubed in it. And we would have y cubed times 4x to the 4th y cubed minus 5 over 16x to the 4th y to the 7th. And now this is multiplication, so we can actually, since this is one number times another number, and this is one whole number, we can actually reduce the y cubed and y to the 7th using our exponent rules. So that would be 4x to the 4th y cubed minus 5 over 16 x to the 4th, and y cubed over y to the 7th reduces to y to the 4th in the denominator. And then our last problem. Remember, we found out that the least common denominator of x, least common multiple of x plus 1 and x minus 4 is x plus 1 times x minus 4. So to find our fraction and simplify, we want to do 5x over x plus 1, and we need to multiply that by x minus 4 over x minus 4. We need to put these parentheses in here now because we need to remember to multiply the whole thing out. A lot of times when we forget the parentheses, we don't multiply the whole thing out like we're supposed to. And we're subtracting now. 4 over x minus 4 times x plus 1 over x plus 1. Now it said perform the multiplication. So let's multiply out our numerators. We're going to keep the denominator factored like it is. And we multiply out the numerator using our distributive property over multiplication over subtraction. And we have 5x squared minus 20x minus the whole fraction of 4x plus 4x plus 4 over x minus 4x plus 1. Remember though, we're subtracting this whole fraction, so we actually have to distribute our negative and make that a plus, and make both of these minus. And now we combine like terms in the numerator, and we have 5x squared, negative 20x minus 4x is minus 24x, and then minus 4 from there, all over x minus 4x plus 1. Remember, you can list the two factors in the denominator in any order because we have the commutative property of multiplication. Here's a couple more, and we'll go from here. The least common denominator of 5x minus 4, x plus 1, and x minus 4, 5x minus 4, was 5x minus 4, x plus 1, and x minus 4. So when we multiply this out, or we want to add these two fractions, we have 4x plus 1 over 5x minus 4x plus 1. We need to multiply both numerator and denominator by x minus 4 over x minus 4. Again, let's remember to put our parentheses in so we remember that we have to multiply the whole thing out, not just part of it. Plus, we have 5x over 5x minus 4x minus 4. We need to multiply numerator and denominator by x plus 1 over x plus 1. X minus 4 was what was missing from these two factors to get our common denominator. X plus 1 was what was missing from these two factors to get our common denominator. Now we're going to actually do the multiplication. Remember, we have to multiply all four. We have to do 4 multiplications here because there's 2 distributive properties. So we have 4x squared minus 16x plus x minus 4 plus, since this is plus, we can put it all over one denominator right away. The previous problem I didn't do that because it was minus and I needed to remember to distribute that minus. But this one, because it's plus here, we can put it all over the same denominator. So we have 5x times x plus 1. That's 5x squared plus 5x. And now we combine like terms in the numerator, and we leave our denominator the same. So we have 4x squared plus 5x squared is 9x squared. Minus 16x plus x plus 5x is minus 10x. And then minus 4. So our final answer from this addition is 9x squared minus 10x minus 4 over 5x minus 4, x plus 1, x minus 4. This last one, x minus 4 and 4 minus x look very, very similar. Unfortunately, they're not quite the same because we know if we were to put a number in for x, say 5. For the first one, we would have 5 minus 4 is 1. For the second one, we would have 4 minus 5, which is negative 1. So we have to figure out what to do here. But they look so much the same. Let's put the x first in both cases. So we have x minus 4, and then remember when we use the commutative property with 4 minus x, if we want to commute this, we have to change it to 4 plus a negative x, and then that commutes to minus x plus 4. So now we have x minus 4 and minus x plus 4, and previously in this section I said if there's a minus sign in the leading coefficient, factor that out. So let's factor out a minus 1. What do we need to multiply minus 1 by to get minus x? We need to multiply it by x. And what do we need to multiply minus 1 by to get positive 4? We need to multiply by minus 4. So 4 minus x is the same as minus 1 times x minus 4. So here we have 4 over x minus 4 minus 3 over minus 1 times x minus 4. This is multiplication, so we can actually change this, the minus and negative, to plus. So that becomes 4 over x minus 4 plus 3 over x minus 4, which is 7 over x minus 4. So this problem started to look a little complicated, but this is one that you really have to remember. Big yellow star. We even color it in. X minus 4 is, or 4 minus x is the same as negative 1 times x minus 4. And in general, a minus b is the same as negative b minus a. We'll be doing that quite a bit, where we'll be switching the a minus b to minus b minus a, or anything that's a difference like that. Let's look at these problems now. 6w plus 12 times 5 over 6w plus 12 minus 4 over 5w plus 10. 6w plus 12 factors into 6 times w plus 2. 5w plus 10 factors into 5 times w plus 2. So our least common denominator is going to be 6 times 5, or 30, times w plus 2. What do we need to multiply the first fraction to get this denominator? We need 5 over 5. So we have 5 over 6w plus 12 times 5 over 5. Let's remember to put that in parentheses, minus 4 over 5w plus 10 in parentheses times 6 over 6, because that's what was missing after we factored it. So now we're going to do 25 over, we can leave it factored as 30 times w plus 2, 25 minus 24 over 30 times w minus 2. 25 minus 24 is 1 over 30 times w plus 2. So that one's done. Here, our least common denominator of, we have 3x over x times x minus 5 minus 7 over 4 times x minus 5. Our least common denominator is going to be 4x times x minus 5. And then we get to multiply by what's missing. So 3x over x times x minus 5. We're missing a 4 in the denominator, so we're going to multiply by 4 over 4. Minus 7 over 4 times x minus 5. Here we're missing an x, so we're going to multiply by x over x. Now we're going to do our actual multiplication. So 3x times 4 is 12x, minus 7 times x is 7x. And remember before, there's nothing to distribute this for the minus sign, that's why we can put it over one fraction right away. And that's all going to be over 4x times x minus 5. That, the combining like terms in the numerator, we get 12x minus 7x is 5x over 4x times x minus 5. The x's actually divide out because they're it's 5 times x and 4 times x minus 5, so it's all multiplication right now. The x's do divide out, so we end up with 5 over 4 times x minus 5. That's it for today. Talk to you tomorrow.